All right, I'm going to be starting a new project where I'm going to go through this data and clean it up. Let me do a sound check really quick. All right, sound is good. So, um, this data is based on some strategy, which I'm not going to get into here because it doesn't matter, but basically it will short certain stocks or long other stocks based on some criteria. And there's this is taken from the output of the program that does the backtesting, and it just has three columns. The actual CSV had more, but for what I'm trying to do, we only need these three columns. This is entry date, the time it enters the trade, and the entry time. It doesn't have the exit time or any other of the other stuff that the original CSV had, but this is all we need for what I'm trying to do. And basically, this data, um, the performance looks better than it should be. Um, so the reason for that is some of these trades, it takes, let me go back to this one. You could not actually get in. They're called bad prints, or I guess there's other names, but it's when a stock shows that the backtest looks like it would have taken a good trade, but if you go back and look at the data, um, it would have never been able, either you would have never been able to take that trade because it would have been too quick. I guess if you were running a bot, it's possible, but there's other issues with these trades that you would most likely not want to take them. Or this data is just bad, and the backtesting data is bad, and that happens with different data sources. This is one data source. The data I use to backtest is another data source, but they also have the similar data. So, um, basically, I want to try to filter out some of this data. Here's one example. Here's another example. This one actually I would keep in the data set. I think you might be able, these, by the way, these are minute bars, and you might be able to take this trade. Hold on one second. Um, you might be able to take this trade, so I would personally leave this in. But I'm showing this for a reason, which I'll get to in a minute. And then this one is one you would probably not either be able to take or not want to take. So you got to filter those out. There's several ways you could do that. I'm gonna do it a certain way, but yeah, there's other ways you could do it. Going back to this picture, this right here is not a bad print. I was hovering over this section and it creates a vertical line. So, um, but going back to this picture too, the problem too with doing it 100% with some algorithm is, like you might not want to remove this trade, and there might be a lot of them like this where the algorithm would, the one I'm going to use would filter it out, but you might want to include it. By the way, as a side point, in all stock data that you're backtesting, I don't know how much you would see this in crypto, but even with crypto or stock testing, you probably want to eliminate some of your better trades, just because you're never going to get, from my experience, you're never going to get what the backtest says. You're going to get worse than that for several different reasons. So you should probably eliminate some of your best ones, and then that will bring down the overall performance of the backtest and give you more realistic results. But aside from that, you also have stuff like this that really makes the backtest look good. So, for example, with this, the backtest would say, "Oh, I shorted it way up here, or wherever it says it shorted it, and it covered down here, and then you get a good result where you would have never been in that trade." And the things I'm trying to eliminate always work in the favor to make the performance look a lot better than it is. So I want to get rid of those. But anyways, going back to what I was saying, I don't want to just run some algorithm and get rid of them. I want to be able to review these as well. So what I'm planning to do is first I'm gonna do it through the algorithm through just Python and pandas, and then after that I'm gonna make it ChatGPT up, which I'll probably use later. I'm gonna make it so basically you import or upload your CSV to a website or a page, a web page, and it will load it and find the ones that it thinks are the outliers and the bad prints, and then it will display them to you, and then you can hit a button to approve it or deny it, and then those will get removed from the actual data set and give you back the CSV with all the trades you actually wanted. So to do that, since it's going to be on a website, um, and you could do a lot of this filtering on a server, on the server side, too, if you wanted to. There's a lot of ways to do this. Right now, I'm going to do it all client side, and so I want it to all just kind of work in the browser. Um, and for that reason, I want to handle CSVs and I want to handle the data checking and data cleaning in the browser. The easiest way I've found to do that are a couple ways. You can, of course, just use like a CSV module to parse the CSV and do the calculations, whatever, all in JavaScript. That's possible. I would not recommend that. If you are just trying to work with CSVs, though, I would recommend using a module instead of doing it on your own. There's a lot of different, maybe not a lot, but there's different things you have to handle, like quotes inside of the CSV values and stuff like that. And it's just much easier using a module than trying to split by commas or whatever the delimiter is and dealing with that yourself. I would recommend using a module when you're working with CSVs. And this is probably the most popular one. CSV parse is really all you would need though, which is a part of this. Um, but then there's two other options, which if you're doing what I'm trying to do, I'd recommend. So you can use Pyodide. I think I'm gonna end up using this because you could just code directly with Python basically. This allows you to run Python in the browser. The one downside of this is it's I think the size of it's kind of large compared to some other libraries, so it will take a second to load, and it just loads a lot of more than most libraries, I think, if I remember correctly, and if it's still the same. It's been a while since I've used this. Another option is this, which I think is smaller. It's all in JavaScript, but it's similar to Pandas. They designed it similar to the Pandas API. So I don't think I don't know how fast it is. I'm guessing it's optimized in some ways, but I don't think it's as fast as like Pandas that's optimized with C. Um, in different ways they make that fast. I'm not sure this is as fast, but for most data sets, this is probably fine. I think I'll use this, but maybe if I run into issues or it takes longer to load than I want, I might use Danfo. So there's that. Um, I'm going to be using just Vite. Click Get Started and scroll down to this section. I'm just going to run that and create probably a React app. I mean, I haven't used React in a while, but I'll probably just use that. It's very popular. Um, and then the last thing is I want something that will display the candlestick chart. So I'm going to be using lightweight charts from TradingView. It's actually, I just found this today. I didn't know this existed. There's other charting libraries out there, but this looks very good. This has existed for a while, so. But yeah, they have a license down here that you have to do this. I'll do that later, but yeah, this is seems I've used TradingView. It's very popular, and I think their lightweight chart library is probably gonna work pretty well for what I'm trying to do. So there's that. Um, First thing, let's grab this data set and load it into a pandas data frame. So I'm going to create a Jupyter Notebook, filter stock data. So to create a Jupyter Notebook in CSV code, you just type some file name. I'm going to make it the same as the folder name, but it doesn't have to be. And then you use the extension IPyNB, and it'll create a Jupyter Notebook inside of VS Code. And you have to have some extension installed to get this to work, but when you load it up, um, VS Code will just say, hey, you need to install this to work with this kind of file type, and it will, or you should install this to work with this file, and it will, once you install it, it'll work just like I have. After that, first thing I want to do is import pandas as PD, which is common abbreviation, and then load the CSV. So load it into a variable called df, which stands for data frame. Df equals pd.read csv trades.csv. And let's see what this looks like. So again, this is just the same data, but now in a little table format that's easier to read, that outputs when you just put the variable at the end of a code cell in a Jupyter Notebook. So there's that, and first thing I need to do is let's create a function to get minute data, because for all of these, if we want to filter these out correctly, we basically need to, these are minute bars, so we need to grab minute data. So you will need a source of data, but I'm going to create a function to try to make it as general as possible, and not relying on the data source that I have. I already have a bunch of minute data at this path on my computer. So let's just put this here, minute bars path, in a variable uppercase because it's a variable that's not going to change. And with pandas, you can let's return a data frame from this. Let's see, df equals pd.read. All right, actually, let's pass a data frame into this as a parameter, which will be this data frame from the trades. So let's see, get minute data. I think I would want, there's a few ways to do this. I could do it for every entry date. I think I'm going to have this work with just one entry date. And that being said, let me think about this. I could go either way here. Let me think about this. So get minute data for one entry date. Yeah, multiple ways we can do this. I'm just thinking, should I have one data frame with all the minute data for each of these, or just process them separately in their own data frames? For now, I'm going to do them separately in their own data frames, even though it might not be as efficient. Let's just do that then. So I'm going to say, instead of data frame, I'll just say entry date equals, for now, none, and ticker equals none. This will take in two parameters, the entry date and the ticker, and then get the minute data uh, for that ticker and entry date. So, all right, let's just say date instead of entry date. Yeah. Okay. Should make this tickers. Let's just do single ticker right now. Okay. So, and I want to return a data frame. So minute data frame equals get minute data, and we're gonna pass in a ticker. Let's just manually type this in for now. Let's do XOM and date equals this date. Okay, and then to make sure it works, let's output it there and ticker and date. Okay. So what pandas can do is if the files at this path are inside of zip files, or they might not just be regular zip, but some other compression. But pandas will actually, you can leave them zipped, and pandas will handle the extracting from a zip file, or it handles other compression types. Also, it does that automatically, so you don't need to worry about unzipping the data and then passing that other, the CSV within there, or whatever data type in there, to pandas. You can just use read CSV and it'll automatically do that for you. I guess other data types, like if you have Parquet files that are also zipped, that might work too. I haven't tried that yet, but anyways, read CSV. And then we're gonna use, let's import OS, we're gonna do os.path.join. And we're going to use minute bars path for the first part of the path. And this basically just combines file paths with the correct way needed for your operating system, and either / / whatever. And then minute bars path, and what was the other part? Crap. I gotta list the files in this directory because I don't remember what they look like. os.lister. Let's just grab this. Unicode doesn't. Okay. For now, let's do that. Okay. So that's what they look like. And let's go ahead and actually copy this up here and grab all this. Oh, right here. Okay. Minute bars path, and then so it has the date, and then .csv .gzip. So read CSV ospath.join, and then we're gonna have an F string, so I could put the date in there. Date dot csv.gz, and we're gonna create a data frame from that file and return the data frame. So let's see if this works. That's true, and I didn't do the filtering, so let's do that. So data frame equals data frame dot loc. Actually, we could just dot locate where the ticker is equal to ticker. Cool. So there we go. We have open, high, low, close data. I was just seeing if I can find, I think this is actually, one of these is XO. I thought this was XOM, but maybe not. And that would be the first minute, but I don't see the bad print there. Again, it doesn't, the data sources, they're not always, they don't all have the same bad prints or whatever. And maybe I'm wrong about this. Maybe this is another one, but I thought that was XOM. Oh, wait, this is not the right date. Sorry. I need to convert this Windows start into a timestamp. So, actually, does that matter? I think it might for what I'm trying to do. So let me just do that. df timestamp equals pd dot to date time df what is it? Windows start unit equals, I believe those are nanoseconds. And what is it? UTC. I believe this is true by default, but I could be wrong. Oh yeah, and then we need to PD. I forgot how to do this. Yes, ChatGPT. Convert timestamp to New York time, then remove localization. There we go. And it's good to use New York time when you're dealing with stock market data because the time zones changes don't matter. There's no weird daylight savings time stuff. And it just matches most data sources that you're going to deal with. So I'd recommend doing this. You don't have to do the localized thing, but it removes this extra stuff, which is, I don't know, kind of, I don't like it in the data set. So that takes a second. Oh, and I realize why I'm not seeing this. It has pre-market data. So we probably just want to get regular hours data. So let's do that. We want df dot equals df dot loc, and let's just do this on a separate line. Df dot loc df timestamp between, wait, what's between time now? And this takes a start time and an end time, so we're gonna do pd dot timestamp 9:30 is when the market opens. 09:30. You can use this format of a string. And the other one would be pd.timestamp. I think it's not inclusive, which is what we want, because the 15:59 timestamp close is the last bar in the regular trading hours. So let's see. Index must be, right. To use this, you have to set the index to a date time, which we could set it to timestamp. Um, that's actually recommended. I believe it's faster when you're working with this kind of data. For now, I'm not going to do that though. So let's just put that there. Let's put like um, requires. A lot of times too, I put an extra comment thing there because if I ever want to just grab both of them, it's easy to uncomment. Otherwise, I have to make sure I don't grab this, and then I uncomment it, and it's invalid code and all that stuff. So I usually put an extra on there for blocks like this. But anyways, what was I saying? Oh, I'm gonna do a different loc. Requires datetime index, which I'll just say recommended. Okay, anyways, we're not going to do that. We're going to do something similar to this. And we're going to say timestamp greater than or equal to that, and df dot timestamp is less than that, but not equal to. And you have to surround these when you're doing this operation where you have two filters basically in the same loc. You need to use an ampersand if you want both of them. You could also use or if it's either or. So yeah, let's see if this works. That did not work. Let's see, timestamps greater than or equal to 930, and df timestamp is less than we want dot time, I think. I think there might be an issue here. Series object is not callable. I think since it's already a date time, we just want dot time. I'm not sure. Series object has no attribute time. Hold on, let me just figure this out with ChatGPT really quick. What's wrong? P dot to date time. Okay, I may or may not need to do this. Let me use this though. It's not a function, it's just a property. Okay, date, time, and timestamp, yeah. So I do need that. So it was right. Let's throw these in a variable up here called market open. Date time. I don't know, just market open time. Market close time. And put this here. And put this here. And same with this. And this. Hopefully this is working now. There we go. Yeah, it's still not the one that I was thinking, but yeah. But yeah, there we go. there's a filter for this date, and then it has the open timestamp. Something's up here. What is this? Wonder why it... Did this get halted or something? This actually might be legit, and it got halted or something. Some crazy news. I have no idea what's going on there. But you can see it skips from 9:30 to 9:37. So I didn't take as good of a screenshot as I should have. It doesn't include the timestamps. But maybe this is 9:30 and that's 9:37. I don't know. But anyways, you can see the data now starts at 9:30, which is market open New York, and ends at 1600 or 1559 because the close is at 1600 New York time. So that's good. So yeah, that's the start there. When do I have to go? I have to go in about an hour or so, maybe less. All right, anyways, we have that part. Next part is to go through each of these and um just so it's easier to see, I'm going to drop some of the columns I don't care about and reorder them. If you're dropping columns, there's a couple ways to do that. You could do df equals df drop, and then you could say columns equals, and the columns you want to drop. Another way is just, I think this is called slicing. Basically choose the columns you want. With the syntax, I think you could use loc here too. I don't know. When I'm doing this, filtering, I always do it like this when I'm selecting columns. I just do it with this format. Because these, I believe you can use loc for the most part too, especially if it's just one condition. But yeah, I usually always use loc, and then if I'm selecting certain columns and reordering the columns, I use this format. And by the way, on some of these, like the drop, you can do like drop, and then there's an in place thing where you don't need to reassign the variable, but I've gotten used to this reassigning the variable to the filter data, and I don't know, just it's less confusing to me if you do it that way for the most part. So let's see. The columns I care about, let's print out the columns. This is an easy way to do this. Run all, and then grab these and put these in here and rearrange them however you want. I want to have the timestamp at the beginning, and then the ticker, open, high, low, close. Don't care about Windows start. We'll do volume at the end and transactions, I guess. So I didn't clean up too much, but I did reorder it. It's easier to see that way. Let's see what this looks like. Gotta do that. All right, cool. You could also do, let's see, return df dot reset index, drop equals true, and here I will do an in place. True. So, resetting the index will basically make it so it starts at 0. If it's just using an integer index, if you're using a timestamp index or datetime index, I've actually never used it for that. I've always used it just if you have a regular integer index. It's just cleaner to see. And then if you don't do drop, let me just show you what that looks like. Let's make sure this works first. Something's wrong. What is wrong here, actually? What's wrong? Oh, right. I'm returning the return value of this function. Yeah, that's the problem. There we go. I want to return the data frame itself, not the return value of the function. And actually, in this case, what it was saying is I actually don't want in place because the return value is a data frame, so that's what I want to return. If you don't use in place. There we go. So yeah, it starts at 0 now. Instead of whatever number that it from the other data set it got, and it pulled data out of that data set, so it starts, the numbers will be based on that. Because that this data was not at the beginning of the data set. That's why you saw the other numbers, um, the larger numbers. But yeah. And then, oh yeah, if you don't do drop equals true, I'll just show what that looks like. It basically adds another index because it doesn't drop the original. It just makes it a new column, not an index, with the original. And then you might want that for certain reasons, but in my case, I don't want that. Okay. Um, there's that. What was I gonna do? Okay, I have them in order. And then for each of these, so if you look at this, the problem is, or the way to filter these out is you want to find the top of the candle and the high, um, and compare it to, is this some sort of outlier? And we don't have any examples in these pictures, but it could also happen on the low. It'd just be the opposite. It would be down here instead of up here. And you don't want to use the, this could work, but I don't think you want to use the open or the close because the open on a red candle is at the top and on a green candle it's at the bottom. So I think you want the top or the bottom. So let's do that. And when you're working with this kind of data in pandas, you want to usually create new columns for these things, because it's a lot faster. You don't want to do like minute data dot iter rows. Some cases you might want to do this for index row in iter rows. This goes through each row. Print row dot ticker. Let's just say. And it should print XOM every time. Here, let's just do something more obvious. What's going on? So yeah, you could do stuff like that. Try to avoid this. It's a lot slower than creating a new column with some sort of data based on the, derived data based on the another piece of data. And then with that column, if you want to create a new column and a new column, when you're working with this sort of data, you usually want to create new columns because it's a lot faster. It's optimized in pandas for working with columns, I believe, that are the same type of data. Okay, so um, let's see. So I want to create a column called top. So we can do that by doing top equals Um, so we can say, I'm gonna do it this way, but I think you can use max as well. Um, let's do it this way for now. So I'm gonna use like kind of a ternary operator here, which is different in Python than it is in other languages, but so I'm gonna say it's gonna be open if um and top is gonna be the top, not the high, like not the high of the whole candle, but the top of the bar part of it, which would be the open or the close. Um, it's open if minute data df open is greater than minute data df close, else minute data df close. And the bottom will be very similar. And I will use max as well and see if those match up. The truth of a series is ambiguous. So maybe you can't do it like this, like the way I'm thinking. If I ask ChatGPT, I'm pretty sure it'll just say use max, but I'm just curious. How fix? Oh, NP-where. Okay. Using apply. Okay. Can I use max instead? Okay, nice. So this is a much better way to do this. I'm just wondering, so yeah, you would need NumPy here. Let's just throw that in here for now. Oops. And let's just see if this will work. Um, and then I'll use max instead. This actually might be faster. Oh, by the way, I'm going to make this faster. Or hold on, let me just paste this in here. To make this faster, I'm going to create another cell here. I'm going to call this data df equals this. And then df equals data df dot copy. So I don't want to run this every time I run. So, oops, data df. Okay, cool. And then let's grab this. And run it. Wow, that's actually really slow. Hold on, what part of that is slow? Can't be this part, right? No, that's instant. Oh, never mind. Ignore me. It's not what I meant. Minute data df dot copy. Data df is get minute data. What am I doing here? Data df. Sorry, this should be separate. Here, there we go. Df. Basically what I'm doing is loading this once and then here, let's see. And now I could just load it from the copy, so it gets a fresh, clean copy every time. I run it from here down. And just to prevent myself from accidentally running this, let's comment that out. And that way, this stays in memory. It says it can't find the variable, but it's still in memory in this notebook session. So it should be faster now when I do run all nice. Okay. So yeah, that's fine. The top is that. Can we find a counterexample? Yeah. So this time it's the open, next time it's the close. Okay. So that's one way to do it, but let's do max. I think that for max, do I need to use apply? Better a faster way? Yeah, I don't know why it said did it say apply? Oh, never mind. Using apply with max. Maybe this does use apply? I don't know. I don't know why it said that. But this should be good. And it seems to work the same way. That one's on top, and then now that one's on top. Okay. And then you want the bottom is min. So top, bottom, top, bottom. Okay. And now you want another column I want is the percentage change from the top to the high. So let's do what do we want to call this? Top to high, and we'll do bottom to low. So for this, we're gonna do a similar thing and do percent change. I believe is built in and works. And then that's where we're gonna replace this with top to high, bottom to low. Wow, that's it didn't work. Expected one to array, got an array of shape. Um, let's see. Ah, dang it. It froze. Percent change can only apply to a single series. Ah, right. Percent change, percent change, yeah, is from one data point to the next. This I'm doing a comparison. So you have to use the percent change formula, which is final minus initial divided by initial. And then it does shift, which I know what it's trying to do, but I actually don't want to do that. Shift would be if I had data similar to how I was thinking before. So let's remove shift. So top to high, and then we can test this with a calculator. So let's do percentage change calculator. I mean, it should be fine. I like this one. Let's do, whoops, top is 109, 116. High is 112.81, 109.16, 109.16, and 112.81, 3.34. Yep, looks good. And then bottom, let's just do an absolute on this. I think we'll want that later. We'll just say absolute 2 to make it clear. Don't need it for this, but I'll put it here anyways. Okay. Just to make sure on the downside, it uses positive numbers too. I think you could probably just, instead of using absolute, go bottom, low, low, but whatever. Um, so there's that. And then we want the, so now we want to get the standard deviation of these. And then to find the outliers, we'll just find a number. We'll sort by standard deviation. We'll find a number that stands out from the others compared to the standard deviation. So let's find the standard deviation first. Let's add all of these in a list. So let's go minute data df, top to high. Oops. Top to high. Plus minute data df. Bottom to low. And I'm going to put these in a list. So to list. Actually, can you... Hold on. Can I use .std on two columns? Pandas? If you want, okay, so return a series for each. Yeah, I want to stack. Yeah, stack. Okay, nice. I've actually never done that. So let's do that instead. It's a little bit cleaner than what I was gonna do. And let's print it. Yeah, let's just print it. Std value. Oops. So we get 0.003, which is good. And then we want to take, so let's take this number and divide it by the standard deviation to get a ratio to tell us what would be a large number compared to the standard deviation. Yeah, I think that's what I want to do. So let's do that. And then we want to do top to high, first standard deviation, bottom to low, first standard deviation. And to do that, we just take this divided by std value. I should name this something else, but I'll think about that in a second. Now we have a bunch of columns. Wait a second. Is that... Am I thinking about this wrong? That's a large number. It's not as large as I was hoping for. I'm not sure. I really need to go back and like find. I wish I had labeled what these are. Um, hmm. Because I know for sure this one is really messed up. Like this just doesn't seem that crazy. 109 to 112. But I'm getting a very large, which is fine, but I'm looking for something even more extreme. Um, what kind of numbers do you get if you go the other way? Let me see. Let's do this divided by this. Point 0.10, 0.28. Yeah, so you get low numbers. That's all. Duh. Alright, like this better. It makes more sense. So, yeah, not sure. Anyways, let's do a smart values. Maybe we'll find y equals top to high versus standard deviation. Let's do by this, yeah. And then we want ascending equals false, because I want the largest numbers at the top. Yeah, it is that opening candle, which is not that uncommon for the opening candle to be kind of crazy, so let's see, bottom to low. Probably the same. No, this one got a different number, but yeah, those aren't. So the bottom here would be open to low. I mean, that's a huge move. Maybe that. No, I don't have any examples like that. I don't remember if this is a long trade or a short trade, but all right, whatever. So to solve this, obviously I can go back in a chart platform to see it and figure this out better, but I think this would be a good time to just work with the charting library and look at it that way. I'm gonna have to do that anyways eventually, so I could do that next. Let me think here. What the plan is, though, I basically want to find a number that is kind of, I think, common, like a common number where we can find these between um, any ticker, and I'm expecting it to be a lot higher than like 18 or what was the other one? 9. I'm expecting it to be a lot higher than that since I don't think these are that crazy. Like 109 to 112 is not that crazy. Oh, this is actually, yeah, it's 109 to 112. It's just not that crazy. Um, so yeah, I want to find some number that definitely should be an outlier that I can use across all the tickers. But to do that, I have um, to know what I'm looking at because I don't think XOM is any of these, and I don't think that's even an outlier. It might be this actually, but I swore it was. I thought this was XOM and it went up to like 128, and this was like whatever 10 something, but I don't know. But yeah. Next thing I'm going to do is work with the charting library in the React app. Let's get that started, and I might stop right there. Let's see how much time I have. About 15 minutes or so. I'll just get that started and stop there. So, let's go back to Vite website. Just here. Grab this. Let's copy it from there. Um, let's make a new folder in here called client and open this. Um, let's call this filter stock data. Yeah. And we're going to use, I have a bunch of stuff in here. Solid I used on the last project. Svelte I've used recently. I don't know if I've ever used Preact. Maybe Vue I've used a while back. Vanilla, I'm not going to go with that for now. I think React is has a compiler now. It's a lot better. I'm going to go with that. I'm not going to do TypeScript. I'm just going to do JavaScript. And I forgot what SWC is. Let's look that up. What is Java RJS plus SWC? Probably be good to ask that in a new prompt anyways. And it's not working at all. There it goes. Speedy Web Compiler is a fast compiler written in Rust. Is that right? Is that really it? I thought it was something else, but okay. I don't see a big downside, but whatever. We'll just go with regular. I've always used that. I thought SWC was something else, so I never used it, but yeah. Let's actually move this out. I'm gonna rename it client for now, so it doesn't clash with anything. And then delete client. And then, what? Alright, let's just close this. Sometimes VS Code doesn't work with folders very well. In Windows at least. Let's just call it client. Okay. And then we want to switch into that folder, cd client. What? Oh, I'm already in client. npmi to install the dependencies listed here. I could delete this. Okay, npm run dev. Cool. Let's remove some of the boilerplate stuff. Leave that up for now. I like to use a div here and class name of app, and then get rid of all this other crap. Div and div test. And go back to that, and there it is. Has some default styling. Get rid of the React and Vite logo. Get rid of that. What else is in here that we don't care about? All that's fine, I guess. Background color. Why am I not getting that? Oh, because the theme. Um, eh, actually don't want any of this. We'll use all of those though. Get rid of this. Keep all that for now. Cool. Hold on. Yeah. All right. And let's grab, what do I want to grab here? Let's grab, close this. Let's grab this. Usually you don't want to use a, CDN because um, I mean it's okay. I forgot there are a lot of times because you're using the whole thing and like all the code, and you can do some tree shaking or whatever if you have the library installed. It will only bundle together the stuff you need. But for now, I don't care. I know there's multiple ways to include. Oh, they don't have a public folder anymore, or public HTML. Interesting. Okay. Um, I actually don't know how to do this in a React app. I mean, there's multiple ways to include this. I think you could just use import syntax in React app. How do I use this CDN? Froze again. Um, can I do it without HTML file? Like with import syntax? Because yeah, I used to do it here, but I guess they don't have that now. Yeah. Use dynamic imports may not be the most efficient way. You know what? Yeah, I am just gonna install it rather than do this. So let's do that. Oh, gotta install it in the right folder. I'm sure this package is okay, but you know, shouldn't be just randomly installing things on your computer unless you know what it is. But I'm sure this one's fine. I hope it is. It's from a large company, I believe, so I think it's fine. So let's see, use React. Um, let's see. Oh, there is an index right here. Oh my gosh. I don't know why I didn't see that. I was expecting it to be in a folder or something. Whatever. Here, you know what? For now, let's uninstall. I'm not even worried about this. It just takes up extra space on the computer. I know it's not a lot, but whatever. rather just use a CDN for local development for now if I can. Um, there we go. So let's do script source equals that. Cool. And now let's use one of their examples. Let's see what it looks like. Actually, what is this? Create chart. So let's actually use the ChatGPT example. I'll throw it inside of a component. Let's say new folder, components, new file, chart.jsx. Don't need that. Create chart, chart ref, use ref. The ref is the div. So we have a ref to this, a reference to this div. That's where it's going to insert the chart. And it uses the use effect to clean it up here. And when this loads, creates a chart and displays it. So let's grab that. Import. Oops. Yeah, this is fine. Import from components slash chart JSX chart, and let's just throw it here. Oops. There we go. Let's see what this looks like. Absolutely nothing right now. Might be an error. Okay. Cannot read undefined reading create chart. Okay, got it. Oh, right. What? What's that? I don't understand that. Declared but never used. Hmm. Let me see. I'm having trouble with this one. What's wrong? Code submit, but there's a couple issues. Using create chart directly. Oh, right. The reason it's using window, um, is because, it's thinking I'm doing this. So, to be honest, I think you could just, yeah, we could just do that. Not sure, actually. Let me see what happens here. Failed to resolve import. Right. Hold on, let me see something really quick. Get rid of that, get rid of that. Let's do console.log window. This is one problem with using a CDN. I think I'm just doing it wrong, to be honest. What? Window. Lightweight charts. Create chart. What did I have before? Alright, let's see if that works. There we go. Yeah. Why does that look so terrible? I don't know. But, anyways, that's pretty cool. It's an interactive chart that you can use. And yeah, I would just have that, and then I'd have a couple buttons here to say approve or deny, for the data set to be included in the data set. And we want a candlestick chart. Let's at least do that. Add line series. Let's actually look at the documentation. I will do this soon. I'm not gonna do it right this second. Lightweight charts, documentation, get started. Series types, candlestick. Add candlestick series. And the type of data you need is, let's just grab this. See what that looks like. Nice. Cool. And then just trying to think. Yeah, there is the way they had to use the imports was better. Let me see something. What is that called? IDB keyval. Right. That's what. This is a good way to do it. I could use an import statement right here in the HTML. But yeah, I think I am maybe just going to install, I don't know. I'll think about it. Just install the library. I think I actually will. Actually, for now, yeah, I'll just wait. Yeah, I gotta figure this out. It's not. What if I don't do a fixed width? What does it do? Okay. Maybe there's a way to do an automatic, but let's do 1,000 by 1,000. See if that looks better. Not that much height. Let's do 800. Looks better. And maybe 1200. Not a big deal either way, but cool. All right. We'll figure that out later, but we got that going. The next thing to do would be to just adapt this sorry, this data open high low close into this. And all you really have to do, I believe, is just like here, let's just test that really quick and then I'll stop there. To JSON, oops. Wait, dot. Why am I not getting any code hints here? Data df is not defined. There we go. To JSON? Let me see. No, well, maybe. What is it called? Orient equals records. There we go. Timestamp, ticker, yeah. So that's all you need to do with that. Maybe rename the columns and include only the open, high, low, close columns. Rename that maybe, I don't know. Put it in a different format, but yeah. That's all you need to do for that. And I guess one other thing I could do is the iodide for now. I do want to see how long that takes to load as well. We'll also use a CDN for that for now. Oops. So let's grab that. Throw it in here. And how do you use this? Which sets up an environment. Okay. Await load iodide. So that would be in here. In the use effect. And we'll call main. Let's actually just copy this example. And in general, from what I remember, you don't want to, you do not want to make this callback inside of use effect async. If you do anything async, you want to make a separate async function. Does it warn you? What is this? Yeah, effect callbacks. What is it? ESLint. Nice. So there's that. Load iodide. Let's do window. Let's see what happens here. Print test. Let's see how long this takes to load and print. 1, 2, a couple seconds. 1001, 1002. And let's see how big the size of this is. and network. Wait, what? Lightweight charts. I thought this was. Oh, disk cache. Disable cache.